Hello Basement Programmers and welcome. This is Tom with basementprogrammer.com. This is episode 4 in my series about IoT for the .NET developer. As with many of these videos, there's a companion blog post over on basementprogrammer.com. You can use the video and the blog post in conjunction. Look for the blog post titled Pizza Delivery IoT Project Part 2, published on April 7th, 2023. The blog post has photos and code snippets. Now in this video, we're going to interact with the IoT components connected to my Raspberry Pi device through .NET code. This will allow us to flesh out the device application so that we can start building the cloud side of the application in the next video. Now on my development board, we'll look at in a few minutes, I have a temperature and humidity sensor, I have an LED, and I have a magnetic switch. Each of these is going to be part of the overall solution. In this video, we're going to work through the code necessary to make each one of the items work correctly, and then we're going to see about building out some more high-level functionality in the application. As always, the complete source code is available on GitHub. It's github.com/basementprogrammer. You want episode 4 folder in the IoT samples repo. Now if that folder isn't there when you go to have a look, you probably just beat me to it, so click the watch button on the repo and you'll know when I have it updated. Side note, you can also find the code in the rpi.net repo in the same account. The rpi.net repo is going to be the ongoing source code in its current state, whereas the IoT samples folder is designed to take a snapshot of the code as I'm working on it. So if you really want something to go along with the blog post and the video, go to the IoT samples repo. If you just want to grab the source code at its current state, wherever we're at, go to the rpi.net folder. Now, if you like the content I'm creating, please let me know by hitting the like button on the specific episode and subscribe to my channel. Also, your feedback is always welcome, so feel free to email me at Tom, that's T-O-M, at basementprogrammer.com. And with that, let's code. Okay, so here we are over by my IoT board, my device. Over here I've got my Raspberry Pi. You can see just the edge of it connected here. On my breadboard setup, I've got a couple of things. So first off, I've got a temperature and humidity sensor. Now these are fairly inexpensive devices. I bought about a 10-pack for, I think it was about $12. So you can get them in bulk, about $1, $1.25 each. I do recommend having a few of these on hand, mainly because at one point when I was moving my board around, my connections got disconnected and I accidentally connected the wires incorrectly. So the way this is set up is 3 pins. The leftmost is your +5, the rightmost is your ground, and the center is your data pin. Well, I accidentally connected the ground to the leftmost and the +5 to the rightmost, obviously backwards, and it doesn't take too long before this the plastic on this unit actually melted. So not a good result there. So buy a couple of them just so you have one spare. Be very, very careful. Make sure you've got +5 and -5, +5 and ground connected correctly, and then your data pin there. Over here I've got it's a simple LED, single phase, single color, red LED. And as always, I've got a 1 kilo ohm resistor in series with the LED, because if you don't, you can quite easily burn out the LED. So make sure you have that in series. The center pin for my temperature sensor is connected to a GPIO pin, and we'll see that in the code. One of the sides of my LED is connected to another GPIO pin over on my board, and so I can turn it on and off. And then over here you can see I've got 2 jumpers or 2 connections. One's going to ground, One's going to another GPIO pin. We've got a terminal block here connected to a simple magnetic switch. Okay, the idea is this switch is going to be part of the overall solution. Now, when the switch is in an open state and the magnet is off to the side, nothing's happening. When the switch gets closed, this will be like the container gets closed, or the lid gets closed. This will signal my application that it's time to start collecting and sending the data from the temperature and humidity sensor. Okay, so that's going to periodically check the two values, temperature and humidity, and send them up to the cloud-based solution. Now, when I get to the end of the delivery, I would open up the box, which would disconnect the switch. This will signal to my application it's time to stop sending data up to the cloud-based solution. Now, what's going to happen is the temperature and humidity sensor readings are going to go over to the cloud. This is going to connect to AWS's IoT core service. We'll then process the data as it arrives and make some decisions about it. If we determine that the temperature and or humidity sensors or readings are out of bounds from what's acceptable, I'm going to send a message back to the application, which will then trigger the alarm to or the LED to blink on and off. This will be our alarm that something is out of bounds. Yeah, and this might indicate to the delivery person not to deliver the pizza. Now, obviously, the idea of the pizza use case is a little bit silly, but if you think about how you could extrapolate this to other use cases where you need to monitor temperature and humidity of a shipping container, say, medical supplies, for example, or vaccines, we could very easily find a legitimate use case for this data or for this setup. So that's where I'm kind of shooting for with this project. Okay, so we're going to now jump over to my desktop and look at some code. Okay, so here we are once again looking at some code. You can see this is Visual Studio Code. At the moment, I am remoted into my Raspberry Pi desktop. So you can see there via SSH connection deskpi.local. That's the Raspberry Pi we were looking at earlier. It's sitting behind me. The project I have, I've got a simple command line application here just called RPI. I've got a library I'm calling rpi.net, and that's where I'm going to build out the functionality necessary to interact with everything on this device. And then I've got rpi.net.tests. My intention is to build out some unit tests for this project as we go. At the moment, there's nothing in there. So that's going to be a work in progress. I don't know if you're like me, you always you start creating projects like this and you have the best of intentions to do all kinds of code coverage and automated testing, and sometimes it falls by the wayside because there's so much fun in interacting with the devices and all that stuff. So, all right, here we go. So what I'm going to do is all the functionality is going to be built in this rpi.net library that I've got there, and then the console application is just going to be a simple application to drive the logic loop. So let's start off with creating some functionality to drive the warning light. So that's going to be the little LED. And what I want to do is first we're going to create some functionality to turn it on and turn it off. And then what I want to do is build some functionality so that once I trigger it, it can continue to blink on and off as it goes without me having to do that necessarily in code all the time. Okay, so I'm going to create a class new file, warninglight.cs. Now, one thing I've done, let me show you in here, the RPI.net project, we're actually going to have to add some references to the project. So here we go. I'm going to add 2 package references into this. The first is going to be this system.device.gpio. So the Raspberry Pi has a general purpose I/O controller built into it. This library has the code necessary to interact with that GPIO board and do things like opening up pins, turning them on, turning them off, things of that nature. So that gives us the basic functionality to interact with things that we would want to connect to the board. And then there's this IoT.device.bindings. Now what this does is this has a collection of classes that are built around some common sensors and devices that can be attached to this. So one of those devices is the temperature and humidity sensor that I have. So this basically just saves me having to write all the low-level code to interact with the sensor and deal with the messages coming out. So I need to add those 2 references here. I'm going to hit save. And then let me jump back. Okay, I'm going to get the message about restoring, so I'm going to click the restore button, and that's going to download the packages from NuGet. And now I want to work on my warning light. So my warning light, I'm going to add in the reference to system.gpio, device GPIO. So that's going to allow me to turn on and turn off the pins that are connected to my device. Next thing I'm going to do here is I'm going to stub out my namespace. Oops. And class. And I'm calling this warning light. All right, so I want to have a reference to my GPIO controller. I want to track the light of the status of my light, whether it's on or off, and we'll initialize that to be false. And the pin number. So the pin number is going to be the GPIO pin that we are connected to. Okay. And I'm going to create a public controller. Oops, let's expand that. There we go. Okay, so public controller, we're going to take in the controller object. We're going to instantiate the controller in our main class, and we're going to pass in the controller and the pin number, and we're going to save the controller reference and save the pin number. And the other thing that's important is we need to open the GPIO pin in output mode. Output allows us to send commands to do things like turn on the light and turn them off. That's as opposed to, say, input mode, which we would use for the temperature and humidity controller. Okay, so now controlling the light from an external source is a very simple process of, oops, we'll create this function called blink light. It's a very simple process of figuring out whether we want the light on or off based on its current status, and then using the controller to write to the pin number either high, turn it on, or low, turn it off. All right, let's save that. Now if we jump back to our program class, which is over here in the console application, what we can do is create a warning light class. And actually what we need to do to start off with is we need to create a GPIO controller. Oops. Now, before we go any further, let's just see about running a .NET build command. Okay. My LED is connected to GPIO pin 18. So we'll pass this in. And then let's do some very simple functionality, which says while true, and we'll sleep for a second. So what we're going to do is, hopefully, as long as I haven't made any more silly typos, we're going to blink the light about once every second. Do a quick build, which incorrectly. And before I hit that, let's switch the camera over really quickly. And okay, so we can hit the run command now, and that's going to obviously build behind the scenes and get ready to go. And you can see now on the board that my code is working correctly as we're going through, and it's flashing about once every second. So that's the main driver loop from my application going, turning it on and turning it off. So that means that the first bit of functionality I wanted to accomplish, the warning light, is now complete. All right, so I did just say that the LED functionality was complete, but actually I did miss one thing. So what I want to do is I want to create the functionality that I can trigger and have the light flash by itself without having to drive that from my main application code. So what I'm going to do is come down here and we're going to add a timer. I'm just going to call that warning timer. Let's we're going to create that. We'll set up that timer there. We're going to create the handler, which is really just going to call my blink light function on the regular cadence. And then we're going to create the method that we'll use from the main application to do the blinking timer, do the blinking light, or to trigger this. There we go. So we're going to have this enable warning flag. We'll call set warning from the main application. It'll trigger that enable warning flag, and then it's going to say, well, if we're enabling the warning, we're going to change the timer to trigger immediately, and then every second thereafter. And then if not, we're going to disable the timer by telling it by setting the values to infinite. Okay, so this is going to enable it, this is going to turn it off, and that's just basically going to tell the timer whether to trigger every second or not. The rest of the functionality is just going to be that blink light, which we've already said monitors the status and turns it either on or off. Okay, so there we go. And we can close out the warning light. Okay, now the next thing I want to do is I want to set up my code to interact with the magnetic switch. So this is going to tell my application when to start reading data from the temperature sensor and when to stop reading data from the temperature sensor. Now what we can do here, again, we've already got the GPIO controller set up, and a switch is a fairly basic set of functionality, so we don't really need that high-level class like we do for the warning light. So what I'm going to do is we're first going to have want to set these. We want to have a variable for the pin that the switch is attached to. Now this is going to be pin number 17. Next thing I need to do is set up the switch here. I'm going to open that pin. So switch pin. So we're going to tell the controller to open that pin. And now there's a pin mode input pull up. So input tells us we're using this as some form of input, in this case a switch. And the pull up engages a pull up resistor, so basically it doesn't burn the unit out, it doesn't burn the pin out when we're basically shorting it to, if we basically short it out. So we're going to do, so controller, open pin, pass in the pin number, again number 17, and pin mode is input pull up. Now, I don't want to have to check every single time that I've got a reading on the switch. I don't want to have to keep polling that. So the GPIO controller has some functionality that I can use to register for the state of that pin changing. So we're going to use that here. So controller, register callback for pin value changed event. We pass in the pin that we're monitoring, so that's the switch pin. we're going to pass in what event types we want. So rising and falling. So rising is going to be when the switch turns on, and falling is going to be for when the switch turns off. And then we need to pass in the callback that's going to be triggered every time this event happens. So let's grab that and put it in. Okay, so on pin event is going to be that callback. So there we go. And the signature is fairly typical of most .NET events. You've got object sender, and then you've got an events args. So in this case, pin value changed event args. There we go. One of the things in that event args that's going to be passed in is what event type, because we've registered for 2. It could be a rising or a falling. So we're going to switch on there. And then we're going to call the functionality that we added here for set warning. Okay, so if we're triggering it, it's going to be set warning is true. If we're not triggering it, set warning is false. Now, in this case, where I'm basically tying this to the switch state, it's an easy way to see on the board if it's working or not. In the final application, whether we set the warning light or not is going to be triggered by something coming from IoT. So this functionality is going to change, but it gives us a very easy way to test this functionality on the board. All right, now since we are testing, since we're doing the trigger here, we don't want to, we don't want to blink the light in our main loop. So I'm going to remove that. Our main loop is just going to sit there and hold the application open, and what we're going to see is that the light starts blinking based on the state of that magnetic switch. Okay, so once again, I'm going to have to swap the camera over so we can see the IoT board, and we can watch what happens. So. Okay, so now swap the cameras back over so you can see my my IoT development board again. Let's go .NET run. And obviously it's going to rebuild the application and get started. And we've got our hello world. There we go. So the application is just sitting there at the moment and set to go. Well, you can see down here in my camera, my switch is currently sitting open, so there's no events happening. Now if I bring the magnetic switch close, you can see 2 things happening. First, over in the console, you can see a trigger message happened. Okay, the first time we got a little bit of a jitter. We got a trigger, a clear, and a trigger, which indicates that we received messages saying that the switch state was changed. But you can see over here, the switch is closed and the light is blinking. Now if I remove this, we stop the light from flashing. Okay. Unfortunately, the code needs a little bit of updating because the light is in a stuck on state right now. But you can see we had events triggering causing the we had events being triggered by the state change, as evident by the log lines, and the light has stopped flashing. That's it. And again, we can see that trigger events occurred, and the light's flashing. Break the circuit, and the light stops flashing. Okay, so I think we need to fix a little bit of the unintended consequences there, but we're pretty close. So I'm going to switch the camera over. Okay, so what we want to do is look at this set warning false over here on the warning light. And let's just say when we disable the timer, what we want to do is say light we'll just say if light on, then we'll call blink light one more time to turn it off. And we should be good. And I'll test that out a little bit later. Now it's time to move on to the sensor reading, and we'll do that in just a second. Okay, so the final bit as far as interacting with the devices on my controller is to be able to read the data from the temperature and humidity sensors. So first thing I want to do is I want to create a data class. Here we're going to add a new file, and I'm going to call this conditions.cs. And this is just going to contain the data elements from reading the environmental conditions. So it's a very simple class. And we're going to have a double for temperature and a double for humidity. Let's save that. Oh, oops, not save all. Yes. Okay, I'm not entirely certain why this error keeps coming up. I've been having this with issue with my setup recently, but we will close that. And so the next thing I want to do is create a class for my sensor. Now, the library I'm pulling in already has a class that has the elements to interact with the specific sensor. I want to create a wrapper class for that so I can embed my higher level functionality in that class. So I'm going to go, again, new file, and I'm going to call this environmental sensor.cs. I'm going to grab a few using clauses, so sensor and GPIO. And then I'm going to set up my, here we go, save. All right, so now inside of my GPIO, or inside of my class, I'm going to need a couple items. There we go. We're going to need the actual sensor. Okay, and you can see here IoT.device.dhtxx. DHT11. The DHT11 is the sensor that I've purchased, and that's the sensor that you saw on the board. I've got the GPIO controller. Once again, this is the controller that I have instantiated in my main class, and I'm going to pass it in. And as always, I want to record the pin number. Now, this is the pin number that is connected to the center pin on my GPIO. On my DHT11 sensor. So the center pin is the data pin. So that's what this is going to be connected to. And obviously we're going to need an environmental sensor. We're going to need a constructor. Okay, so the constructor is going to take the GPIO controller and the pin number. We're going to record those, and then we're going to create a new, we're going to instantiate the DHT11 class. Now that requires us to pass in a couple parameters. We're going to pass in the pin number. We're going to pass in the numbering scheme, whether it's logical or physical. In this case, it's logical. And that just outlines how the pins on the GPIO are numbered. We need to pass in a reference to the controller. So there we go. And then the final parameter indicates whether or not this device should dispose of the controller. We don't want to do that because we're using the controller for some other things around there. So there's other functionality dependent on that controller. All right. So now what we want to do is we want to say get condition. We're going to create a function called get conditions. And this is going to take in that, that conditions object, and we're going to return the value. So every time we call it, we're going to get back the values. Now, what we'll do, we'll create an instance of the return class. I like to do that at the start so I don't forget about it. And then we're going to use values that come from this units class that we've pulled in for a temperature reading and a humidity level. Oops. All right. Now, in practice, in the early development stages, what I noticed is this device tends to send back a large number of error conditions when you try to read temperature or humidity. So I would call into the device and say, give me the temperature, and it would report false, indicating that it was not successful in reading the temperature. So, and this was in a lot of cases that I was experiencing this. So what I want to do is I want to code for that inside of this high-level class. So we'll go here. I want to set up my condition to say, obviously, I was not successful in reading this, and then I want to create a loop for reading the data from the temperature reading. And what I want to do here is say, I'm going to tell the sensor to try and read the temperature and pass in the out variable. We got a pretty standard call. If it's successful, obviously it's going to update the data in the temp object that I'm passing in. If it's not, I can't rely on the result there. And then what I want to do is have some basic error handling logic. So I want to what I want to do is, on a successful read, I'm going to update the temperature. And on a failed read, I'm just going to sleep and try again. Now, if I get past all of those, if I've tried 20 times and it hasn't been successful, I'm just going to return false and write this up to an error condition. And then failing that, if I am successful, then what I want to do is the same thing. I'm going to do the same logic for the humidity reading here. So I'm going to try get humidity, and then at the very end, I'm going to return conditions. Let's save there. All right, so now I've got the base functionality set and ready to go to create my environmental sensor and then get the conditions. So I'm going to go back to my program. Okay, once again, I need to pass in the controller. And let's see, int okay, environment pin is going to be 16. So we're going to pass that in. Now we've already got this event that's running every second, so let us see about grabbing the conditions. And then let's just say if this is not null, okay, let's save there. Now I'm hopeful once I start running this, some of these odd errors that Visual Studio Code is popping up are going to go away. So let's have a quick look and see. Actually, let me just make sure before I do that that everything is saved. There we go. Okay, well, we do appear to be building and running, and there we go. We're starting to get some data out from the sensor. Now, you can see it's not responding quite every second, and that's because of the number of errors that come out. So, but you can see it is returning data. And if we interact, sorry, just turning around there, I connected the magnetic switch. You can see there we had a trigger, and if I were to show you, you'd see that the light's blinking. So we can see the data coming back. So I will show you one more thing before I wrap up this. Let's go back to this environmental sensor. I mentioned I mentioned before that the sensor did return some error conditions quite often. So let's have a look at that, and I'm just going to write out a my typing is not good. I'm just going to write out a full stop every time we get an error condition here for both that, and then let's do the same for humidity, and we'll put an asterisk. Now I'm going to go save, and we'll just run this once again. So okay, so we've compiled this here, and now you can see a whole bunch of full stops coming out here before we get a successful condition reported. And then another lot of error conditions. And now we We get a few successful readings. So this is just the way that that sensor works. So you can see there why I wanted to build that loop in for retrying, because I don't want my core application to have to deal with those sorts of errors. So I've embedded that in the in the high level class. So there we go. Complete source code for all of my videos can be found on GitHub. You can find me there at github.com/basementprogrammer. Thanks for watching my video. If you found this video helpful, please hit the subscribe button. It helps you to know when I have new content out, and it helps me to know I'm creating useful content for you. You can always find me at basementprogrammer.com, on Twitter, and the Basement Programmer podcast. Details listed here. If you have any comments on this video, or you just want to get in touch, you can always email me. The address is tom@basementprogrammer.com. And I'll see you next time.